Hey guys, so we are still using the Pythagorean theorem to find the length of a side or the distance between 2 points. I'm going to show you how to set up distance in this next slide after this one, but here are three examples where we are trying to find one of the legs. We are given C, so anytime you're given the C, you're given the hypotenuse, you want to set your equation up as a subtraction problem. Just makes it a lot easier. So you know that 7 is C, so that's what you're going to put first. We were going to square that. And instead of adding, we subtract. So you take C and square it, and then you subtract whatever leg you're given. And that will give you your missing side. So in this case, we're looking for A. Again, A and B are kind of interchangeable. I can simplify. I've got 49 minus 9, so that gives me 40, and that's A squared. And the same thing as before, you want to make sure you take your square root. Don't leave it as just 40. That answer will show up on your answer choices a lot, and you'll see 40 and you'll click it and you think you got it right. Don't forget, take the square root. So in this case, it's not a perfect square number, so we're going to round it to approximately 6.3. Okay, example 5, again, we're given the hypotenuse. We are given C, so we want to subtract. You always set up that 25 first, so 25 squared, minus whatever side you are given, so that's minus 7 squared, and that gives me B squared. So 25 squared is 225 minus my 7 squared, which is 49, and that gives me 576. So B squared, and then we would have to take the square root. That one did come out to be a whole number of 24. Okay, so when you're given C, anytime you have the hypotenuse, you need to set it up as a subtraction. Okay, here's our example with a word problem. So we need to draw a picture. So it says that Bobby leans a 15-foot ladder against his house. Well, here's our ladder. Okay, our house is going to be, we're just going to have the vertical side of the house. And it says he placed it 4 feet from the base of the house. Now, this is not a great picture. And you can label it. Next, that ladder is going to be 15 feet. And again, it's not to scale, so it's okay. We've got 15 there. I don't know why those kind of stuck together. Let me get rid of that 4 and move it. So 15 is the length of the ladder. And 4 is going to be that base, up how far it was from the base of the house. So now we are trying to find either A or B. It doesn't matter what you call it. Okay, I think in this example, let's see what I called it. I think I called it A. So you could go back and label that if you needed to. It doesn't matter as long as you set it up as a subtraction problem. So I've got 15 squared minus 4 squared equals A squared. Well, 15 squared, I believe that's 225. And then we're going to subtract 16. So that will give me A squared. I'm going to take the square root, and that gives me 14.5. Okay, one last example so you can see how they'll set it up for the distance. So we are trying to find the distance between these 2 points. Well, anytime it's on a grid like this, you're just going to create a triangle. So this going across, and then we have this going up. That gives us our triangle. We created a right triangle, and now you can label those sides. Going across the bottom, we went across 4. So we can label that base as 4. Up the side, 1, 2, 3. We went up 3 spaces. So now I can create my equation. My distance that I'm trying to find is my hypotenuse. So if you're trying to find the hypotenuse, you are going to set it up looking for C. So I've got 3 squared plus 4 squared equals C squared. I'm going to add 9 plus 16 and get 25. And the last step is going to be to take the square root. So 5 is equal to my distance of that C side or that hypotenuse. So that's how you can use the Pythagorean theorem to find the distance between 2 points. Basically, you're just finding that missing side. So when they ask for distance, you can create a triangle.